All right. The concluding presentation of this particular talk is related to a speculative model on the work that is being done in IMTC, and this is combined work of the IMTC activity group for UC IoT. And that has been concentrating on doing a systematic way of approaching how to end up being able to develop UC-specific IoT profiles. And in this case, there has been an investigation into various use cases that are relevant to UC, like room systems, what are the peripheral controls or ambience controls that might be involved in a room system for conferencing and so on and so forth. And there are other use cases also that are possible, whether UC systems can themselves generate events, and events can be considered sensors for either long-term maintenance purposes or short-term maintenance purposes. And so these are some of the use cases that were considered. And yes. UC is Unified Communications. Sorry. So UC is for Unified Communications, and in this particular talk, I'll be mixing or interchangeably using UC and RTM. RTM is real-time media. UC SDN, as the initial standard was, or rather initial specifications were generated in IMTC and then now incorporated into ONF standards for higher layer applications, is now that activity is continuing to extend this single domain specification into the public cloud version of that. And so in order to not restrict itself to just UC, RTM has been coined as the term. And so therefore here onwards it is going to be RTM. So if you see me using UC and RTM in the context of SDN, so they are equivalent. So among the many things or many use cases that we were considering, we were thinking in terms of SDN, because there is work that is going on in the IMTC on UC SDN and the specifications, just as I mentioned. And in this one particular case, you could see that there are UC SDN is tasked with the goal of trying to provide automated quality of experience in UC call environments, whether they are audio or video, end-to-end. And so therefore, aspects of parameters that are controlling the quality of experience are quality of service at the network layer, admission control or bandwidth management, and as well as traffic engineering, routing around disconnects that might happen in a network. So the three combinations are tasked with providing a better quality of experience. So I'll be talking about that briefly. But just to give a backgrounder on the basis for overview of IoT. So I'm going to touch upon aspects of IoT to build up this case, as well as aspects of the UC SDN, so an overview, and then subsequently try to arrive at what we were trying to do with trying to arrive at or rather fashion an IoT model for UC SDN events. So in other words, we are trying to do the UC SDN events as kind of virtual sensors and virtual actuators. And so that is kind of leading to an interesting situation. And so therefore, to do that, before we go there, I want to be able to provide some grounding on the UC IoT model that we developed in this case. So the basis of IoT we have already seen. I'm probably going to not go too deep into this, like it is a machine-to-machine technology that allow both wireless and wired systems to communicate with other devices. So, and we have already seen and heard enough of IoT that I'm not going to go too much into the IoT aspects of that, but trying to frame the case for UC. So, or unified communications and how IoT can play a role. So, there are different ways that IoT can play a role. As I mentioned, there may be ambience in a conference room environment, for example. It could be lighting or the temperature of the room getting darker, or there is a presentation that is now initiated, so you want to put a focus light or a tracking light with the presentation or the presenter, etc. So those are the cases where it is possible to detect such events and or sense such events, and then respond accordingly with the ability to be able to automatically react to these cases and then adjust the lighting capabilities, etc., etc. So those are external events or external things that are embellishing or enhancing the value of unified communications collaboration experience, for example. So there are other cases where it might lead to pure UC actions, such as starting a conference. In the event somebody is entering a room, or the time has started, and so therefore this room has been allocated, and so therefore you want to be able to initiate some conference event. There is also another possibility where you want to be able to think in terms of UC events inside components in a conference room environment, or other types of calls on for desk phones or desktop videos and so on and so forth, where you want to be able to continually monitor the health of a given component and then be able to report on that component in an indirect fashion through the connected nature of the already established UC system. So there are different categories that are ripe for being exploited as UC IoT use cases. So in the long term, you want to also be able to gather such cases over a period of over a range of deployments, and perhaps over a range of tenancies, and then be able to identify some patterns of behavior, whether it is product level or component level or other usage type of patterns. So that could be leading to either a real-time events or a long-term events that could be analyzed or subject to analytics in the cloud. And some of them could be actually, of course, also candidates for local analysis, such as in the case of edges, such as the room hub, for example, in the case of UC, what could equivalently be a fog environment. So in this particular case, it is more of deriving what the event is and then deciding to defer the event to a UC infrastructure, such as a UC application server. So in this case, we will talk about the UC IoT, just a brief touch upon what we are doing in IMTC. So we are being a forum for IoT and M2N info exchange for IMTC, which includes liaising with other SDOs and alliances that are working on this. As well as we want to be able to build a library of use cases, which we have done, and arrive at a UC applicability profile, which eventually could be led to feed into working on test plans and interop testing. IMTC is essentially interop profile development and testing alliance, but it also develops specifications, which has happened with UC SDN. So these kinds of capabilities are what is being worked on in UC IoT. So in the case of UC, you can say there are peripheral integration that we talked about just now, but we are also talking about cloud integration in the northbound context, such as the information that is collected and then processed intermediately in the UC IoT gateway, and then eventually going up to the cloud or the infrastructure for subsequent long-term and near-term analytics. So now, what is happening with UC IoT and SDN? So just an initial introduction on the UC SDN itself. So software-defined networks has a framework of how the control plane can manipulate and configure the data plane on the fly for given flows. So now it is therefore possible for being able to provision parameters that are very sensitive to UC, particularly voice is very sensitive to latencies, and video is very sensitive to admission, rather bandwidth as well as latencies for that matter. And so therefore it is important to make sure that before we establish a UC session, that is a call is established between two endpoints or an endpoint and an intermediary, then we want to be able to guarantee the level of quality of service, the bandwidth provisioning as requested in the signaling exchange or the SDP exchange, as well as eventually being able to make sure that in the event there is a flow path that has been determined, that there is something happening in the flow path that is causing a disconnect, then it is possible for the network to automatically reconfigure the flow path around that disconnect and then be able to still continue to establish this, rather than having to scratch our heads at the application layer as to what is going on and how we need to make these changes from happening. In the event that it is not possible for the network to meet the parameter guarantees that it had originally established in the session, it can send a notification to the application layer at that time, at which point it is possible for the application layer to renegotiate the terms of the call and then perhaps reissue that. But that is an exception rather than the rule. So so not only is the quality of experience automated, so that therefore it is possible for eliminating the fact that network is the cause in the case of poor quality of experience, and ensuring automatically that the network is able to very flexibly and collaboratively respond. Automatically respond. On the other hand, there is also that case of diagnostics. That is there is something happening in the network. There may be something that might be wrong with the endpoint. So in a running session, you want to know, rather than in a can you hear me type of situation, whether it is the endpoint or the network. So to be able to distinctly be able to tell where the problem lies in a path of flow, it is best to be able to at least to start with bifurcate the problem to be determined either to be at the endpoint or at the network. So the endpoints are already providing enough information by way of, say, RTCP and other types of mechanisms to say what they view about the network. And in addition to that, it is also true that endpoints also deliver a lot of information about the multimedia capabilities and status of their microphones, speakers, etc. And to the extent possible, and then they are able to convey it to the higher layer UC application. So we will be talking about the case where, given these two information, how the UC application is able to mediate and correlate between the events that it is getting back from the network thanks to the UC SDN framework versus what is happening with the UC SDN with the endpoints, and therefore it can make a determination automatically and take automatic corrective actions. So there are two things that are now happening with UC SDN. Is one, the automated QAE, and the one is about the automated diagnostics. So in both these cases, here is, before we go, so maybe I should probably talk about the case of the QoE case. On the right side, you should be able to see that the lower two layers represent the SDN framework normally, and the network controller box is actually signifying the lower layer of the network control box actually signifies the original SDN framework of the control plane of the SDN framework. The bottom network elements could be the switches and routers and perhaps even SBCs or border control elements. And then the layer, inside the network control box, the upper layer is the one that introduces the UC SDN interfaces. So the one that are controlling or are providing the interface, northbound interface to the higher layer applications to say what kind of quality of experience that they want in quantitative terms. So then the northbound interface automated QoE service now subsequently turns around and then tells the network as SDN controller that these are the parameters that it wants for the 5 tuples of 2 endpoints. So the 5 tuples decide how the path is going to be charted out. So it is the SDN network that charts the path and then identifies the network elements to which it has to program to say to guarantee these capabilities. And then at that point onwards, the quality of service, the admission control, and if necessary, traffic engineering capabilities are built into it. So this is what is happening, and therefore the UC SDN specifications really expose the northbound interfaces, facilitating higher layer applications like like a CUCM, for example, in the case of Cisco's, or Avaya's UC server, or Polycom's conference servers. They can end up being able to program the UC SDN in a fashion that it is possible for the higher that automated guarantees of quality of experience can be provided. So what this really means is that eventually when there is anything that is happening by way of events, so now you can consider these to be actuators. So in this sense, in the quality of experience case, where the flow paths are established, these are all actuators in the IoT context, if you want to model that way. On the other hand, if you want to model it as the service here, this is the automated diagnostic service. It's possible some network events might be happening that causes either a router to go down or a switch to go down, or maybe a disconnect to happen between two network elements along the path, flow path. Then it is possible for such a thing to be discovered and then notified to the higher layer of SDN controller, and in turn the SDN controller will let the higher layer automated diagnostic service know, and then based on policies that are available there, these are going to react to this by either conveying this information to the higher layer UC application, and then coming back to decide what a kind of remedial action needs to be taken. So in these remedial actions, the events like this that are both going down in the event of quality of experience call setup, and in the case of diagnostics, that is happening going up, so which could be considered as the network elements are now becoming sensors to the virtual sensors to the events, virtual events that are happening, and that is bubbling up. In both these cases, it also not only reaches the higher layer infrastructure for remedial actions to be considered, but it reaches even higher for long-term analytics and long-term problem resolutions, or even real-time enactions of remediations that we talked about. So one typical example here is the flow about when the UC application on the leftmost side is trying to let the UC controller to know that it wants to establish a path between the bottom client and the client on the right side, that is with from branch 1 to branch 2. Then the path is set up with the appropriate QoS parameters. As you can see, it is only the network elements that are along the way, like the switches and the routers, that are provisioned appropriately. And so the same thing happens with the provisioning for for admission control, for bandwidth assurance, as well as for providing any kind of traffic engineering rerouting that might be required as well. So so there is, in this particular case, I'll go back to the IoT model. So this is a typical IoT model that we have arrived at, which is easily mappable to some of the models that we have described earlier, that we have seen so far in this sessions. One is related to the device layer, or the IoT sensors and actuators, the clients. It could be a conference room, or it could be a conference endpoint, or it could be a phone or a video desktop endpoint. On the other hand, it could be the access layer, where it could be the hub for the conference room, or the ITP gateway, or anything else. So on one stack, you can see that it is possible for the UC infrastructure to build up UC IoT flow, where we go from the access layer delivering event information through sensors, or receiving actuation information from either the UC information, UC itself, or from other infrastructure services, such as the lighting fixture or the HVAC service for temperature control, etc., like I mentioned in the case of room services. So when this happens, one can see that the stack through which the UC actions go all the way up to the cloud for subsequent analytics and based on the events and other things. So the UC IoT stack goes that way. And it is possible for, and it might be necessary for either the infrastructure and or the cloud services to be delivered from the cloud to be able to initiate or respond to actions that are actually happening on the that are required for actuation purposes. And those services might not necessarily be UC services. So this could be other services. So now one can visualize that one stack is the UC service, another stack could be potentially the UC SDN service. So in which case it is possible to even sense not only on the client side, that is the sensors and clients on the IoT, but it is also that the infrastructure itself could be modeled as a virtual set of sensors and actuators that in turn, when modeled, can very well resemble the IoT stack and IoT sequence of flows. Then it is possible for being able to make adjustments towards the, use the very same IoT model to gather information about the events at the higher layers and then respond to them in an IoT style fashion. So in this sense, this is a case where we are extending the UC SDN to not just one domain, but across a public, as a UC as a service, that is Unified Communication as a service, delivered from a public cloud, and potentially the path crosses multiple potential service providers who have some peering arrangements, and it is possible to ensure the three parameters of quality of service, admission control, and traffic engineering, either through dedicated express routes kinds of models or even peering arrangements that can guarantee that kind of model. So this is one example where if there is a path that has been decided, shown in dotted black paths between two entities that are trying to communicate through the cloud, it is possible for one of the segments to go down, in which case it is then this is sensed by the UC SDN controller, sent up to the UC as a service application, and if necessary, but at the same time, the reaction from the UC SDN controller or the SDN controller itself is going to guarantee that the flow parameters are assured by identifying an alternate path and then rerouting it, so that it is not necessary for either the UC application or the UC SDN controller to do anything more than because this is already guaranteed. So these are two examples, and so therefore, so the IoT model in the UC SDN is something that we are continuing to investigate. This is not a done deal at this time. Is to how does a virtual IoT model help with the UC SDN? So one is to have network events mapped as virtual sensors, and also QoE flow configurations are also mapped as virtual actuators, like I just described. And because of the synergies in stack, as we saw in the case of the UC SDNs for both the QoE and the ADS, the blue figures, this one and this one. It's possible, it is easily seen that up beyond the point where the UC application is sitting, right on top of that, it is also possible for a UC IoT application to sit and then gather these event informations and then make decisions in a UC SDN fashion out of that. So if you can visualize the UC SDN as a control, as a path that analyzes signaling and data media, it is possible to visualize the UC IoT equivalent of sensors and actuator events as a control plane of some kind, where the control and monitoring equivalent is what can be activated for the UC SDN as well, which can consolidate the actions and then provide additional control capabilities to the underlying UC SDN as well as the SDN. So the IoT basically extends the applicability on endpoints to applicability on network as well, the corresponding network when it is UC SDN enabled. And it also helps view SDN as an embedded field of IoT elements. So this is the kind of overlay model that we are envisaging, where in addition to the UC applications that are subscribing to the UC SDN interface, it is also possible for the UC IoT framework itself to subscribe to these and then build the higher layers on top of that. That's all I have. Any questions? Yes?
Where is publisher? So is publisher in the side, right? It's like pub and sub kind of scenario, right? Where is the publisher reside? That in terms of what traffic is it?
The publisher, I mean,
Like in this chart, example.
this one?
Right.
Yeah. So UC application is the one that is responsible for setting up the media path between two people who want to talk, either video or audio video. So which means that is going to communicate to the two endpoints and negotiate the terms of communication. That is, what should be the media looking like. For example, if it is in a SIP communication, the SIP will carry SDP as parameters in the SDP to say what rate you are going to, what codec you are going to use, what bit rate what audio codec you are going to use, etc., and at what bit rate and what frame rates and so on and so forth. So that is a client-server model more than a publish-subscribe model. So it is a communication, two-way communication. So there is no publish-subscribe involved here. But yeah, in some ways we can consider the events as something that is published and subscribed. It's possible for the UC elements, that is the UC gateway, for example, as termed in the fog computing also, the gateways, for example. So the fog it can potentially be subscribing to interested events inside many sensors that might be in the space. So it is possible those events will be once subscribed, then they can in turn deliver those events, and that will be of interest to the if it is possible to program those sensors, for example. So they could be a broadcast type, or it could be other types of specific targeted notification. It doesn't necessarily have to be pub-sub model. It could be
does it also work for like IM kind of communication, like Jabber or something, where your video and audio is there, but you can also text somebody? Does it?
Yes,
does it also
and multimedia involves besides audio and video, which are real-time sensitive in general. It could be chat, and also there is a content channel, which is essentially could be video viewed as video in some senses. It could be even sent as JPEG for. So, to quote a more familiar example for you, WebEx is essentially a content display. Yeah, right. That's correct. Now it is also video and audio supported there.
Right. Thanks.
Anything else? If not, this concludes the IoT session 2. So tomorrow morning, I think at 9 o'clock, the one person who asked this question will be starting the IoT session 3. Richa.